viewers, welcome to our class for today. This is basic science for Jss2. In our previous class, we looked at thermal energy. Today we want to look at light energy. What are the objectives we will cover today? We'll look at what light energy is. We'll look at reflection as it connects to light energy. We'll look at refraction as it connects to light energy. We are going to illustrate apparent depth and explain its dangers to swimmers. Okay, so what is light energy? In a general term, light energy is an energy that has a very great impact in our life. Light helps us to see. Light helps us to see colors. Light helps us to see reflection. Light helps us to keep warm. Okay, light helps us to cook our meals, and light helps us in our everyday life. Now, what is light energy? Light energy, this is a form of energy which helps us to see objects. Like I told you, and light energy helps us to see colors. This light that travels on a straight line help us to see objects. Okay, so light energy travels in waves. They travel in waves, and light energy travel in a straight line. Light travel for about 186,000 miles per second. Some scholars said 186,250 miles per second. So about or more than 186,000 miles per second. That's very fast, you can say. So that is what light energy is. That light energy, this is a form of energy which helps us to see objects. Light energy travels in a straight line. Light energy helps us to get warm. Light energy travels at a rate of 186,000 or more miles per second. So that means that light is important. Light energy can equally be seen in the sun. It can be seen in electricity. When our wire is electrified and you switch up the wire, you're going to see light. The fire wood can produce light, and it keeps us warm. So that is light energy, and these are some sources of light energy: the sun, electricity, and then we have a firewood. Now, we've seen what light energy is. What is reflection? What is reflection? Reflection, this is a property of light. It occurs whenever a ray of light strikes a plane or a polished smooth surface. Reflection happens when a ray of light travels and strikes that reflection. This is a property of light. It occurs whenever a ray of light strikes a plane or polished surface or a plain smooth surface. We'll give you an example of a mirror. If light passes through a mirror, what happens? It's going to reflect and it's going to bounce. That's why we see a reflection of ourselves in the mirror. What about in a polished surface? A polished plyboard. If a ray of light strikes on it, it's going to be reflective. What about the glass windows, glass doors that we see? If the ray of light strikes on it, it is going to do what? It's going to reflect. For example, this is an object. If this ray of light, this straight line signifies ray of light. Once they strike on the surface of this object, it's going to reflect. That's reflection. A process whereby light strikes a polished surface and then it reflects back, like in the case of a mirror, in the case of a polished surface that will reflect light back to us. That is reflection. Now what about refraction? Now let's look at that other aspect. Refraction happens when light bends as it hits an object. Remember that in reflection, the light does not bend. it moves directly and reflects on the object. But in refraction, the light bends as it hits an object. When this ray of light travels from one medium to another medium, okay, it's have different density. For example, if light travels from air to hit the surface of the water, it slows down the course and it changes in its direction. For example, if you see light reflects from the air down to the surface of the water, you see that it will be diversify. It will look like a straight line. For example, if this is the light, or this is the object, and the light flashes, it's not going to be at that straight line we said. It's going to be haphazardly reflecting. It won't reflect straight. It's going to bend over in its reflection. So do this experiment. Go to a river or a swimming pool. Look at the swimming pool as the ray of light reflects inside the water. You see that the ray of light is not going to be in one particular place direct. It's going to scatter itself because it bends over. That is refraction. So it slows down, causing it to change direction slightly. If it's moving like this, its direction will slant. It will slant this way. It will slant this way. In the case of water, it's going to have different reaction. You are going to see it in different pictures. Okay. So this change is called refraction. For example, a glass of water. If light reflects on a glass of water, put a jar, let light reflect on it. It's not going to be in a straight format. It's going to be in a diversified format. That is refraction. Now that is the second objective. So we have seen what light energy is, we've seen what reflection is, we've seen refraction. Now I want to illustrate apparent depth and explain its danger to swimmers. Apparent depth and illustrate its dangers to swimmers. Now let's look at apparent depth. Apparent depth is a depth in which a transparent medium such as water or glass seems to have reflection of the water rays. Let's take a vivid example. You stand by a river, you look directly inside the river. The river looks as if it's very shallow. You look as if you are seeing the depth of the water. That's the sand beneath the water from the rays striking the water. So when you look at it, you will just look at if the water, the depth is not deep. So you look at it and say, once I just jump in, it's not going to be more than my waist. This water is not going to be more than my waist. Only for you to dive into the water and the water swallows you. That is because there is apparent depth in it. The reflection of the light to the river is showing that the water is shallow. But in the real sense, the water is deep. Look at this pictorial illustration. Don't mind me. Just look at what I'm trying to explain. Let's say this is your water. Let's say this is your swimming pool. In here are waters that are found inside the swimming pool. Here stands a little boy gazing into the water. This is his eyes, and he gazes into the water. And he looks as if this is where the depth of the river stops, or the water stops. This becomes his apparent depth to the view of the eyes of the boy. But in the real sense, the real depth is down below here. So assume that this little boy jumped inside this river, thinking that if he gets to this point, and this boy is as tall as this, the water will get to its waist, and it will be all over, and he can just walk out. Only for the little boy to jump inside the water, and the water will swallow the boy. That leads to drowning. So apparent depth, it's very dangerous for swimmers because you might underrate the depth of the water. Meanwhile, the real depth of the water is there inside. That is because of the rays of light emanating from the sun or from the air striking the water, making the depth of the water look very shallow to the eye. but in the real depth of the water, it is very deep. So you don't just jump into the river because your eye tells you that it is very shallow. No, you have to test. You can use a long stick to see the depth of the river before you jump inside. Don't allow apparent depth to make you assume that the depth of the water is very shallow. For example, you can do this. Get a bucket of water, put it in a place where there is light, and look inside it. It will show as if the depth of the water is very small, as if you dip one finger, you'll get to the bottom of the water. Only for you to dip your hands, and the whole of your hand is going to enter, and you've not gotten to the depth of the bucket. That's just a simple experiment. So the last objective is illustrate apparent depth and explain its dangers to swimmers. That's what we're explaining. Don't dive into a water that you have not really looked at the depth. Use an object, a stick, a pole, to look at how deep the water is before you jump in. Don't assume that your eye will gauge the depth of the water, because your eye might not gauge the depth of the water. That will be it on our basic science class. We've been able to cover the objective for the class. We've seen what light energy is, reflection, refraction, then the apparent depth of how it serves. It can endanger the life of a swimmer or endanger anybody's life if you don't properly take notes. So thank you for joining us. Watch the video and rewatch it. Ask your question below the comment box. We'll come to you with another topic on our basic science class. We might continue on light energy in another of our topic, but in other areas of our light energy. Subscribe if you don't subscribe. Share the video if you like it. Invite your friends, your classmates to come watch our videos. We have more than 800 videos on YouTube. We have counseling section, we have sex education section, and we run the Nigerian curriculum from Jss2 to Ss3 for key subjects. What's that subject you think we are not doing here you want us to add? If it's possible, we will add it. What's that question? If you've not responded to any of your questions you've asked, please re-ask it, either in this subject or any other subject. We will get to you. Thank you for joining us. Give us a thumbs up. That will make many people to discover the channel. I'll see you in another episode.